Welcome, dear friend, to this quiet corner of the world, a space for gentle stories designed to accompany you into a peaceful and restorative sleep. Tonight, we begin a journey together, a slow descent into a world of profound stillness and hidden wonders. We will travel beneath the soft, white veil of winter to explore the secret life that lies under the snow. Our story is one of ice and silence, of time held captive in crystal, and of the slow, deep pulse of a world at rest. Before we drift into this frozen landscape, I would be so grateful if you would share in the comments where you are listening from tonight, or perhaps a simple feeling from your day. Your presence here makes this community warmer. And if you find solace in our journey, please support our channel with a like and a subscription, which allows these stories to reach others who might need a moment of peace. Thank you so much. And now, let us begin. Let your body grow heavy, your breath slow and deep, and allow your mind to follow my voice into the high, thin air where our story is born. Imagine, if you will, the vast and silent theatre of the upper atmosphere, a realm of deep, velvet blackness pricked with the cold, distant light of stars. Here, miles above the sleeping world, the air is thin and achingly cold, a place where the familiar rules of water seem to hold their breath in anticipation. Within a swirling, invisible cloud of water vapor, countless droplets of moisture drift in a state of suspended animation, supercooled far below the point of freezing yet remaining stubbornly, beautifully liquid, waiting for a sign, a catalyst, a reason to transform. Our journey begins not with a grand event, but with the smallest of pilgrims. A single, microscopic speck of dust, perhaps a grain of pollen from a long-forgotten summer flower, or a tiny mote of cosmic ash from a star that burned out 1,000,000 years ago, now tumbling slowly through the stratosphere. This unassuming particle becomes the heart of our story, a nucleus around which a universe of perfect geometry is about to unfold. A single, shivering droplet of supercooled water, no larger than the finest mist, finds this particle, and in that moment of contact, the spell is broken. The water molecule, the familiar H2O, instantly remembers its true nature, its crystalline destiny. A phase transition occurs, a change as profound and as instantaneous as a thought, as the liquid water gives way to the rigid, ordered beauty of ice. This is the moment of nucleation, the very first heartbeat of a snowflake. It is a whisper of creation in the immense cold. From this first frozen seed, a miracle of architecture begins to grow. The very shape of the water molecule, with its 2 hydrogen atoms arranged at a precise angle to its 1 oxygen atom, dictates the fundamental law of this new creation. It is a law of 6-fold symmetry. As more water vapor molecules from the surrounding cloud find this growing crystal, they do not attach randomly, but are guided by invisible electromagnetic forces, the subtle push and pull of hydrogen bonds, to lock into place in a perfect hexagonal lattice. This is the foundational blueprint, the genetic code of the crystal, ensuring that no matter how complex it becomes, it will always be a variation on a theme of 6. You can picture it as the first 6 lines drawn by a master architect, a promise of the intricate cathedral of ice that is to come. As the nascent snowflake begins its long, slow descent through the atmosphere, its journey becomes its story, and the air itself becomes the ink with which that story is written. It drifts through layers of varying temperature and humidity, and each subtle shift changes the way the crystals grow. In colder, drier air, the hexagon might grow into a simple, solid plate, or a long, elegant column, a form of minimalist, crystalline beauty. But should it drift into a region slightly warmer and rich with moisture, the magic of dendritic growth begins. The 6 corners of the hexagon, reaching out into this fertile environment, grow faster than the flat faces. They shoot outward, forming 6 primary arms, like the first bare branches of a winter tree. These arms then become the canvas for ever more intricate detail. As they extend, they create their own tiny currents of air and zones of depleted moisture, influencing the growth of the branches that sprout from them. Tiny instabilities, a momentary updraft, a slight shift in temperature, cause side branches to form, always echoing the fundamental hexagonal rule, creating a pattern of breathtaking complexity and perfect, repeating symmetry. The journey of a single minute through a pocket of humid air can add a filigree of delicate, fern-like structures to each of the 6 arms, while a subsequent passage through a colder layer might cap them with simple, sharp needles. The snowflake is recording its autobiography as it falls. Every gust of wind it has ridden, every cloud it has passed through, every subtle change in its environment is etched into its form. This is why it is said that no 2 snowflakes are alike. The sheer number of variables on its long, chaotic journey to the ground makes the probability of 2 intricate crystals following the exact same path, with the exact same orientation, vanishingly small. Each one is a unique testament to its own personal history, a frozen diary of its descent. And so, we can imagine this single, luminous flake, now fully formed, a perfect jewel of fleeting artistry, tumbling in the final few feet of its journey. It has travelled for perhaps an hour, a silent, graceful fall from the edge of space to the world of sleeping fields and silent rooftops. Its life has been a dance with chaos and order, and the result is a small, 6-sided masterpiece of transient beauty, ready to finally come to rest. And as this single, intricate messenger settles upon the waiting earth, it joins a silent chorus of trillions upon trillions, each one a unique voice, a distinct story that now merges into a single, collective presence. The focus shifts from the individual to the whole, from the miraculous geometry of the one to the profound, world-altering power of the many. Together, they form a blanket, a great, soft mantle of white that drapes itself over the landscape. And with its arrival, the world begins to change in the most fundamental ways, beginning with the very nature of sound. Before the snow, the winter world, though quiet, still carried the sharp, clear echoes of existence. The snap of a frozen twig, the distant call of a crow, the rustle of dry leaves in the wind would travel far through the cold, dense air. But as the snowpack deepens, a profound and sacred hush descends. This is not merely the absence of noise, but an active, palpable silence, and its secret lies in the very structure of the newly fallen snow. It is a substance that is mostly air. Billions of tiny, complex ice crystals lie gently upon one another, creating a porous, labyrinthine structure filled with countless pockets of trapped, still air. When a sound wave, which is a vibration of air, travels from the open world and strikes this surface, it does not bounce off. Instead, it enters this soft maze, and as it tries to move through the intricate passages between the crystals, its energy is dissipated. The wave forces the delicate ice structures to vibrate, converting the sonic energy into an infinitesimal amount of heat, and the sound simply fades into nothingness. The snowpack becomes a perfect acoustic absorber, swallowing the vibrations of the world. And so, a walk through a freshly snow-covered forest is an experience of sensory alteration, a feeling of being wrapped in a quiet so deep that you can almost hear the beat of your own heart, as if the entire world were holding its breath just for you. This same gentle architecture of air and ice that quiets the world also cradles it in warmth, a beautiful paradox at the heart of winter. The very air that feels so bitingly cold on our skin becomes a source of protection when trapped within the snow. This is the principle of thermal insulation. While the surface of the snow might be exposed to temperatures far below freezing, this deep, porous layer acts as a barrier, a magnificent duvet woven by nature. The warmth that is constantly radiating up from the deep earth is prevented from escaping into the frigid atmosphere, and in turn, the bitter cold of the air is prevented from penetrating down into the soil. Just a few feet of snow can maintain the ground level temperature at or near freezing, even when the air above is tens of degrees colder. It creates a stable, insulated microclimate, a sanctuary from the harshest extremes of winter. This insulating property is not just a curiosity of physics, it is the fundamental condition upon which a hidden world of life depends, a promise of shelter that we will soon explore. It is a reminder that sometimes the softest things in the world provide the most profound strength, that a barrier made of fragility and air can be more effective than one made of solid stone. And as this blanket protects the ground from the cold above, it also engages in a grand and elegant dance with the light from the sun. This is the phenomenon known as the albedo effect. The word albedo comes from the Latin for whiteness, and it describes the reflectivity of a surface. A dark forest or a deep ocean absorbs most of the sunlight that strikes it, converting it to heat. But a fresh blanket of snow is one of the most reflective natural surfaces on our planet. Up to 90% of the sun's radiation, its light and warmth, is immediately reflected back into space by the countless facets of the ice crystals. This high albedo is what gives a snowy landscape its dazzling, almost overwhelming brightness on a sunny day, and it plays a crucial role in maintaining the coldness of the polar regions and the winter season. The snow actively works to keep its own environment cold, a self-reinforcing loop of whiteness and chill. And yet, this is the same blanket that keeps the ground beneath it from freezing solid. It is a beautiful duality. A surface that rejects the warmth of the sun from above, while tenderly preserving the warmth of the earth from below. But this community of crystals does not remain a loose, fluffy collection of individuals for long. Even in the deep cold, the snowpack is a dynamic, ever-changing environment. Almost as soon as they land, the delicate, feathery arms of the snowflakes begin a process of transformation, a slow settling known as snow metamorphism. Sublimation occurs, where ice turns directly into water vapor, and this vapor then refreezes in other locations. The sharp, intricate points of the crystals begin to evaporate, and the water vapor recondenses in the concave spaces between the flakes, forming rounded connections, or necks, between them. This process, called sintering, is like a slow collective handshake as the individual flakes begin to bond together to link their arms. The snowpack loses some of its airiness and becomes denser, stronger, more cohesive. It is the first step in a long journey of transformation, a journey that can, over immense spans of time, turn this soft, quiet blanket into a flowing river of solid ice. For now, it is simply the world settling into its winter stillness, a vast and gentle weight preparing for a long, deep sleep. But this long, deep sleep is not an empty one, for beneath the stillness of the settled snow lies a hidden kingdom, a secret corridor of life carved out from the boundary between two worlds. This is the Subnivean realm, a word that whispers of its own location, from the Latin for under and snow. It is a space of profound importance, a fragile network of tunnels and chambers that comes into existence the moment the snow deepens enough to create its protective blanket. Its formation is a gentle and collaborative process. The residual warmth of the autumn earth, still breathing its slow heat, melts the very lowest layer of the snowpack, creating a sliver of humid air. At the same time, the sturdy skeletons of last summer's grasses, the low-lying shrubs, and the uneven contours of the ground act as tiny pillars and rafters, holding the weight of the snow just an inch or two aloft. Into this shallow, protected space, a world of activity awakens. For the small, warm-blooded creatures of the forest and field, the voles, the shrews, and the mice, the arrival of the Subnivean zone is the opening of a winter palace. Life is no longer a desperate scramble across a frozen, exposed surface, a terrifying stage where they are visible to every passing hawk and owl. Instead, they can now disappear from the view of the sky world, entering a labyrinth where they are shielded from the biting wind and the piercing gaze of predators. They move through tunnels of their own making, their warm bodies and constant passage helping to maintain these hidden roadways, creating a secret map of trails known only to them. Here, in the dim, blue-filtered light that penetrates the snow, they can forage for seeds, roots, and hibernating insects, living out their quick-pulsed lives in relative safety, their world entirely contained within this thin, life-giving layer. This hidden world, however, is not without its own subtle challenges, for the very blanket that provides protection also restricts the flow of air. As the soil beneath continues its slow, quiet respiration, as microbes break down organic matter and plant roots continue to breathe, they release carbon dioxide, the same gas that we exhale with every breath. In the open air, this gas would simply dissipate, but under the dense, settled snowpack, it becomes trapped. The concentration of CO2 in the Subnivean zone can slowly begin to rise, sometimes reaching levels that are many times higher than that of the normal atmosphere. For the creatures living within, this creates a state of chronic hypoxia, a gentle but persistent lack of oxygen. This invisible pressure can influence their behavior, making them more lethargic, or sometimes forcing them to undertake a risky engineering project. The creation of a ventilation shaft. A vole might tunnel upwards, creating a small, almost invisible hole in the surface of the snow, a tiny chimney that allows the heavy carbon dioxide to flow out and fresh, clean air to seep in. These shafts are lifelines, but they are also points of vulnerability, tiny betrayals of the secret world below, which a keen-eyed fox might learn to recognize. The very architecture of this realm is therefore a delicate balance between safety and survival, a world shaped by the slow breath of the earth itself. The physical structure that makes all of this possible is perhaps the most magical transformation within the snowpack. At the very bottom of the snow, where the temperature gradient between the warm ground and the cold surface is steepest, a unique kind of crystal begins to form. Water vapor, rising from the melting base, travels upwards through the snow and refreezes onto the existing crystals above. But it does so in a peculiar way. It forms large, hollow, cup-shaped crystals, known as depth hoar, or in the language of the Inuit, pukak. These crystals are not the delicate, feathery dendrites of a falling snowflake. They are granular, faceted, and structurally weak, barely bonded to one another. The pukak layer is like a foundation of loose, crystalline gravel. While this makes it unstable for a skier passing overhead, it is a paradise for a tunneling vole. The loose, crumbly nature of depth hoar allows small animals to excavate their tunnels with ease, pushing aside the large, airy crystals to create their network of passages. It is the very instability of this basal layer that provides the space and freedom for the subnivean world to flourish. And so, just beneath our feet, under a surface that appears uniform and still, lies this complex and fragile city of crystal. It is a world built of frozen breath and earthly warmth, a testament to the quiet, persistent, and ingenious pulse of life that finds a way to thrive in the heart of the great white silence. While this hidden world bustles with the quick, warm-blooded pulse of survival, another, much deeper stillness settles into the very fabric of the winter landscape, a strategy based not on movement, but on an almost complete cessation of it. It is a form of profound patience, a quiet trust in the return of the sun, and it is practiced by creatures both large and small. This is the slow, dreaming pulse of hibernation, a journey into a state that lies somewhere between life and death. For an animal like a groundhog or a brown bear, the preparation is an autumn ritual of feasting, of building up the internal reserves of fat that will serve as fuel for the long winter ahead. Then, in a secluded den, insulated by earth and snow, the great slowing begins. The process of torpor is a controlled and deliberate descent into suspended animation. The heart rate, which might beat 80 times a minute in the summer, slows to a barely perceptible 5 or 10 beats. The breath becomes shallow, with minutes passing between each quiet respiration. Most profoundly, the internal thermostat is turned down, and the body temperature plummets from a warm 37 degrees Celsius to just a few degrees above freezing. The animal is no longer fighting the cold. It has, in a way, joined it, reducing its own energy needs by over 95%, surviving solely on the slow metabolizing of its stored fat. It is a state of deep unconsciousness, but it is not a simple sleep. It is an active, physiological state of suppression, a masterful conservation of life's fire, banking the embers so that they may be rekindled in the spring. This elegant solution to the problem of cold is not limited to those who can sleep the winter away. An even more precise and molecular defense exists within the very cells of smaller creatures. For many insects, amphibians, and fish that must endure freezing temperatures, the greatest danger is not the cold itself, but the physical damage caused by the formation of ice. As water freezes, it forms sharp, jagged crystals that can pierce and shred the delicate membranes of a living cell, causing irreparable harm. To combat this, life has evolved a remarkable tool: anti-freeze proteins. These are not substances that lower the freezing point of water in the way that salt does. Their function is far more subtle and beautiful. These specialized protein molecules patrol the fluids within an organism's body, and when they encounter a tiny, nascent ice crystal, they recognize its specific structure and bind to its surface. By attaching themselves to the crystal lattice, they physically block other water molecules from joining, effectively stopping the crystal's growth. They don't melt the ice, they simply contain it, keeping it at a microscopic and harmless size. It is an act of incredible biological precision, like a team of masons surrounding a single brick to prevent a wall from ever being built. This allows an insect like the woolly bear caterpillar, or a fish in the Arctic Sea, to survive even when their body fluids are cooled far below 0 degrees Celsius, their life protected by these vigilant molecular guardians. The plant world, too, has learned the art of stillness. For the great deciduous trees, winter dormancy is a carefully orchestrated retreat. Triggered by the shortening days and falling temperatures of autumn, hormonal signals travel through the tree's tissues, initiating a systematic shutdown. The process of photosynthesis ceases, and the precious chlorophyll that gives leaves their green color is broken down and reabsorbed into the branches and trunk, revealing the vibrant yellow and red pigments that were there all along. A special layer of cells forms at the base of each leaf stem, neatly severing the connection and allowing the leaf to fall away, conserving the tree's water and preventing damage from heavy snow. The living tissues within the trunk and branches increase the concentration of sugars in their sap, creating a natural antifreeze that helps protect them. The tree enters a state of deep rest, its metabolic activity reduced to a bare minimum, its life force withdrawn deep into its roots and core, waiting. This same profound patience is encoded into the heart of the next generation. Many seeds, scattered in the autumn, possess a built-in biological clock, a requirement known as cold stratification. They will not germinate, no matter how ideal the conditions of moisture and soil, until they have experienced a prolonged period of deep cold. This mechanism ensures that a seed does not sprout during a deceptive warm spell in late autumn, only to be killed by the coming winter. The cold is a necessary trigger, a signal that the hardship has been endured and that the spring that follows is real. It is a form of memory held within the seed, a deep and ancient trust that after the long, frozen sleep, there will always be an awakening. And while the humble seed holds the memory of a single winter, waiting for its predetermined awakening, the snow itself can hold the memory of 1,000 seasons, a memory that, with enough time and immense, silent pressure, transforms its very nature from something soft and ephemeral into a force of geological permanence. This grand transformation begins in those high, cold places of the world, in the vast polar regions or atop the towering mountain ranges, where the warmth of the summer sun is not enough to melt away all of the winter's snow. Here, the cycle of the seasons leaves behind a remnant, a thin, white layer that survives the thaw. The next winter adds its own blanket, and the summer that follows leaves its own survivor, and so on, season after season, century after century, a slow and patient accumulation of frozen history. As the layers build, the snow at the bottom of this ever-deepening pack begins to feel the weight of the world above it. The delicate, six-armed crystals that once drifted so lightly from the sky are now subjected to a crushing pressure. Their intricate arms are broken, and their delicate structures collapse, and the process of metamorphism that began when they first landed now accelerates dramatically. The sharp points melt under pressure, and the water refreezes in the voids, slowly reducing the airspace and rounding the sharp edges, transforming the fluffy snow into small, dense, granular pellets. This intermediate state, no longer truly snow but not yet solid ice, is called firn. You can imagine it as the awkward adolescence of a glacier, a compressed and grainy substance where the memory of individual snowflakes is fading, merging into a collective, unified mass. This process of firnification continues as the burial deepens. At a depth of perhaps 30 meters, the firn has been compressed to the point where the grains are so tightly packed that they seal off the passages between them, isolating the remaining air from the atmosphere forever. These tiny pockets of air become bubbles, trapped witnesses to the ancient world, a secret we shall return to later. As the layers continue to build, and the firn is buried deeper still, under hundreds or even thousands of feet of accumulated weight, a final, magical transformation occurs. The pressure becomes so immense, so relentlessly powerful, that it squeezes the fern grains together, forcing them to recrystallize. The smaller grains are consumed by the larger ones, and they all begin to fuse, growing into large, interlocking crystals of solid, transparent ice. At this point, there is no air left between the crystals, only the bubbles trapped within them. The substance has been fully reborn. The light, airy powder that once covered the ground has become a dense, monolithic mineral, as solid as rock, yet born entirely of fallen snow. This is the birth of glacial ice, a process that can take decades in some places and millennia in others, a slow, patient alchemy driven by gravity and time. With this change in substance comes a profound change in appearance, a shift in the way the ice speaks with the light. Freshly fallen snow, with its countless tiny crystals and trapped air bubbles, scatters light of all colors in every direction, reflecting the entire spectrum back to our eyes, which our brain perceives as the color white. It is a canvas of pure, undifferentiated light. But dense glacial ice is different. It is largely free of the air bubbles and myriad surfaces that cause such scattering. When sunlight enters this pure, solid medium, it begins a journey. As the light travels through the ice, the very molecular structure of the frozen water, the way the H2O molecules vibrate, begins to absorb the longer wavelengths of the light spectrum. The reds, the oranges, and the yellows are soaked up by the ice, their energy converted into tiny vibrations. The shorter, blue wavelengths, however, are less easily absorbed. They penetrate deeper into the ice, sometimes traveling for many feet, until they are eventually scattered back out towards the surface. And so, what emerges from the heart of the glacier is this filtered, concentrated, luminous blue, a color that seems to have a depth and a soul to it. The deeper and denser the ice, the more ancient it is, the more profound and startling is its blue. It is the color of time itself, the light of 100 forgotten summers held captive in a crystal. This vast body of ice is not a static monument. It is a living system, with a metabolism of its own. Climatologists speak of a glacier's mass balance, the delicate equilibrium between accumulation and ablation. In the high-altitude accumulation zone, snowfall adds mass, like a slow, steady inhalation. In the lower altitude ablation zone, the ice melts, evaporates, or breaks off into the sea, a long, slow exhalation. The health of this magnificent frozen creature, its decision to advance or retreat, is written in this simple, elegant balance, a yearly accounting of winter's gifts and summer's withdrawals. And to be poised is not to be static, for this colossal body of blue ice is in a constant state of slow, inexorable motion, a form of movement so patient it reshapes the very bones of the world. A glacier is, in its essence, a river. It is not a river of liquid, but a river of solid, a river of frozen time, and like all rivers, it must flow from a higher elevation to a lower one, pulled ever downward by the persistent, gentle hand of gravity. The sheer weight of the ice, thousands of feet thick, creates a pressure so immense in its depths that the ice begins to behave in a way that seems impossible for a solid. While the uppermost layer of a glacier, roughly the top 50 meters, is brittle and rigid, the ice below that threshold enters a different physical state. Under the crushing weight from above, the ice crystals themselves, though still frozen solid, gain the ability to deform and stretch, to slide past one another without breaking. This process is called plastic deformation, or ductile flow. It is a slow, internal creep, a movement that happens on a molecular scale, as the entire ice mass oozes downhill under its own weight. It flows not like water, but perhaps more like a river of unimaginably thick honey or pitch, its movement imperceptible from moment to moment, but utterly relentless over the course of a year, a decade, a century. This is the deep, silent engine of the glacier, a powerful, internal current of solid ice. In many glaciers, especially those in more temperate regions, this internal flow is complemented by another, often faster, form of movement. At the very base of the glacier, the boundary where the ice meets the bedrock, the immense pressure can cause the melting point of the water to drop slightly. This, combined with the Earth's own geothermal heat rising from below, can create a thin layer of meltwater at the glacier's sole. This layer of liquid water acts as a powerful lubricant, decoupling the vast weight of the ice from the rock beneath it. The entire glacier, as one enormous mass, can then begin to slide downhill on this slippery film, a process known as basal sliding. The groans and creaks that echo from deep within a glacier are often the sounds of this titanic movement, the sound of a mountain of ice slipping across a continent. The combination of this basal sliding and the internal plastic flow determines the glacier's overall speed, which can range from a few inches a day for a slow-moving alpine glacier to several miles a year for the fast-flowing ice streams of Greenland and Antarctica. This relentless, heavy movement makes the glacier one of the most powerful erosive forces in nature, a silent and patient sculptor of landscapes. As it flows, it fundamentally reshapes the earth beneath it through two primary methods. The first is plucking, where meltwater seeps into cracks and fissures in the bedrock and then refreezes, expanding like a wedge. As the glacier flows forward, it freezes onto these loosened blocks of rock, from small pebbles to boulders the size of houses, and rips them from the valley floor, carrying them along within its icy body. The second method is abrasion. The rocks and sediments that have been plucked and embedded into the bottom of the glacier act as a gigantic piece of sandpaper. As the glacier slides, this coarse, debris-laden ice grinds against the bedrock, pulverizing, scraping, and polishing it, leaving behind long, linear scratches called striations that record the direction of the ice's long-vanished flow. Over millennia, this dual process of plucking and abrasion carves the sharp, V-shaped valleys created by rivers into the wide, smoothed, iconic U-shaped troughs that are the signature of a glacial landscape. And while the deep ice flows like a fluid, the brittle surface ice cannot. As it is carried along on the current of the deeper ice, it cracks and shatters under the stress, especially as it moves over bumps or steep inclines in the bedrock below. These fractures form deep, gaping wounds in the glacier's surface, known as crevasses, chasms of blue and white ice that can plunge hundreds of feet down. In areas of particularly rapid or chaotic flow, the surface can shatter into a terrifying, impassable maze of tilted ice pinnacles and towers, a landscape known as a serac field. These features are the outward expression of the immense forces at work within, a testament to the powerful, silent river flowing just beneath the surface, a river that carries mountains within its heart and carves continents with its patient, irresistible touch. And yet, for all its immense power to shape the outer world, the glacier's most profound secret may be the delicate, unchanging world it carries locked within its frozen heart. While the glacier moves and grinds and sculpts the land, its own internal layers, especially in the vast cold heart of the polar ice sheets, remain remarkably distinct and undisturbed, a perfect vertical archive of time. This is a library of winter, where each year's snowfall is a new page laid gently upon the last. To read the pages of this library, scientists undertake remarkable expeditions into the harshest environments on Earth, drilling deep into the ice of Antarctica and Greenland. With hollow drills, they extract long, cylindrical columns of ice, pristine pillars that can stretch for miles in length, bringing them carefully to the surface. Each of these ice cores is a tangible piece of history, a continuous record of the Earth's climate and atmosphere reaching back hundreds of thousands of years. The deeper they drill, the further back in time they journey, reading the story of our planet layer by snowy layer. The most astonishing text in this library is written not in the ice itself, but in what is held between the crystals. Tiny, perfectly preserved bubbles of ancient air. As we discovered, when snow transforms into firn and then into solid ice, the air that was once in the spaces between the flakes becomes trapped and sealed off from the outside world forever. These bubbles are not just empty spaces, they are microscopic time capsules, fossilized atmospheres. When scientists carefully melt a section of an ice core in a vacuum chamber, they can collect this ancient air and analyze its composition. It is a direct sample of what the Earth's air was like 50,000, 100,000, or even 800,000 years ago. They can measure the exact concentration of greenhouse gases like carbon dioxide and methane revealing the natural rhythms of our planet's climate long before human activity began to alter the story. They can see the fine layer of ash from a colossal volcanic eruption that occurred on the other side of the world, a faint grey line in the core that corresponds perfectly with a spike in sulfate levels in the trapped air. But the ice holds another, more subtle record of the past, a story told in the very atoms of the water molecules themselves. This is the science of isotopic analysis, which allows the ice to act as an incredibly precise thermometer of the past. The water molecule, H2O, is made of hydrogen and oxygen, but not all oxygen atoms are the same. There is a common, lighter form, or isotope, called oxygen-16, and a much rarer, slightly heavier form called oxygen-18. Both are stable, and both form perfectly good water, but their difference in weight, though minuscule, is profoundly important. It takes slightly more energy from the sun to evaporate a molecule of water containing the heavier oxygen-18 from the surface of the ocean. In a warm climate, there is plenty of energy to lift both the light and heavy water into the atmosphere. But in a colder climate, it is much harder to evaporate the heavy water, so the water vapor that forms, travels to the poles, and falls as snow is disproportionately made up of the lighter oxygen-16. The ice, therefore, becomes a faithful record of this process. By measuring the ratio of oxygen-18 to oxygen-16 in each layer of an ice core, scientists can reconstruct the average global temperature at the time that snow fell. A layer rich in the heavy isotope tells of a warm, interglacial period, while a layer depleted of it speaks of the deep, biting cold of an ice age. This paleoclimatology, the study of Earth's past climates, has been revolutionized by these frozen records. The ice cores have shown us the great, rhythmic cycles of ice ages, driven by subtle, predictable wobbles in the Earth's orbit, and have revealed how closely the planet's temperature has been tied to the amount of carbon dioxide in the air. The ice, which we think of as the embodiment of a single, cold moment, is in fact a continuous, high-fidelity recording of millennia of change, a silent witness that has held its breath and the breath of the ancient world for nearly 1,000,000 years. But the secrets of the ice do not end with the ancient air it has captured, for in the deepest, most isolated parts of our world, the ice itself becomes a blanket of impossible thickness, beneath which lies a realm of liquid water that has not seen the sky for eons. Our journey now takes us deeper than ever before, miles below the surface of the Antarctic ice sheet, to one of the most mysterious and inaccessible places on Earth, a subglacial lake. For decades, scientists flying over the vast, featureless expanse of the East Antarctic Plateau noticed that a certain area of the ice surface was unnervingly flat. Using ice-penetrating radar, which sends radio waves down through the frozen layers, they made a discovery that was, at the time, unbelievable. The echoes that returned to their instruments painted a clear picture. 2.5 miles beneath them, under a solid shield of ancient ice, lay a vast body of liquid water. This was Lake Vostok, a freshwater lake 140 miles long and 30 miles wide, comparable in size to Lake Ontario, and it has been utterly sealed off from the outside world for at least 15 million years. Its existence seems to defy common sense. A liquid world in a place where the average surface temperature is minus 50 degrees Celsius. Yet its presence is a testament to two quiet but powerful principles of physics. The first is the insulating power of the ice itself. Just as a thin blanket of snow protects the ground from a winter frost, a 2.5-mile thick sheet of ice acts as a near-perfect insulator, trapping the slow, steady flow of geothermal heat that emanates from the planet's core. This gentle, upward warmth, unable to escape, is enough to warm the base of the ice sheet to the melting point. The second principle is the effect of pressure. The colossal weight of the overlying ice creates a pressure more than 350 times greater than the atmosphere at sea level. This immense pressure lowers the freezing point of water, making it possible for it to remain liquid at a temperature of around minus 3 degrees Celsius. The discovery of Lake Vostok and the hundreds of other subglacial lakes since identified opened a profound new chapter in our understanding of life. This is an environment of absolute and eternal darkness, of crushing pressure, and of extreme cold, an ecosystem completely divorced from the sun's energy that powers nearly all life on the surface. For millions of years, this lake has been a world unto itself, a potential biological island isolated in time. Life here, if it exists, could not rely on photosynthesis. It would need another source of energy, another way to build the scaffolding of existence. And so, scientists have hypothesized that life in these lakes could be based on a process called chemosynthesis. Instead of using sunlight to convert carbon dioxide into organic matter, these organisms, likely microbes such as bacteria and archaea, would derive their energy from chemical reactions. They might metabolize the minerals dissolved in the water or locked in the bedrock of the lake floor, effectively eating rocks like iron and manganese to power their life processes. They would be true extremophiles, organisms that are not just surviving in these hostile conditions, but are perfectly adapted to them, thriving in a world that would be instantly lethal to almost everything we are familiar with. The very water of the lake is thought to be incredibly ancient, saturated with gases from the trapped air bubbles in the slowly melting ice above, creating a bizarre, high-oxygen environment. For years, scientists have painstakingly drilled down towards this lost world, stopping just short of breaking through, terrified of contaminating a pristine ecosystem that has been evolving in isolation for longer than humanity has existed. To contemplate this hidden lake is to imagine a silent, dark, and patient world. A biological experiment running in solitude for geological ages, a place that redefines the very boundaries of where life can be found, and offers a tantalizing blueprint for how it might exist in the hidden oceans of icy moons far beyond our own planet. And while life may be actively evolving in the profound, watery darkness of hidden lakes, another vast portion of the frozen world acts not as a cradle for new life, but as a perfect tomb, a silent vault of suspended animation for the life of a world that has long since vanished. Our journey now shifts from the solid ice of glaciers to the frozen earth of the far north, to the immense and ancient expanse of permafrost. This is not simply soil that freezes in the winter. Permafrost is defined as any ground, whether it be soil, rock, or sediment, that has remained continuously frozen for at least 2 consecutive years. In many places, this frozen state has persisted for tens or even hundreds of thousands of years, creating a deep, solid layer of permanently frozen earth that covers nearly a quarter of the land surface in the northern hemisphere. It is a sleeping giant, a quiet and unassuming feature of the landscape that holds within it the most astonishingly well-preserved secrets of the last ice age. Its secret is the dual power of cold and anoxia, the absence of oxygen. The process of decay, the slow, steady work of bacteria and fungi that breaks down all living things, requires 2 essential ingredients: warmth and oxygen. In the deep, frozen heart of the permafrost, both are completely absent. The cold grinds microbial activity to a virtual halt, and the solid, icy nature of the ground prevents oxygen from penetrating. As a result, the normal cycle of decomposition is arrested. Organic matter is not broken down and recycled. It is simply held, perfectly and patiently, in a state of indefinite preservation. This natural cryopreservation has turned the permafrost into a breathtaking archive of past ecosystems. As scientists and miners have delved into these frozen layers, they have unearthed treasures that rewrite our understanding of the Ice Age world. They have found the vast, grassy steppes of ancient Siberia, not as fossils, but as frozen, intact root systems and freeze-dried flowers, so perfectly preserved that their colours are still faintly visible. And within this preserved world, they have found its inhabitants. The most famous of these are the woolly mammoths, unearthed not as skeletons, but as complete animals, with their shaggy coats of hair, their skin, their muscles, and even, in some cases, the undigested meals of their last day on Earth still present in their stomachs. These are not fossils in the traditional sense. They are frozen mummies, time travelers from a lost epoch. The preservation can be so perfect on a microscopic level that scientists have been able to extract viable DNA, and in one incredible instance, found liquid blood within the frozen tissues of a 42,000-year-old mammoth. But the preservation is not limited to these giants. Ancient horses, bison, and even tiny ground squirrels, curled in their hibernating burrows, when the deep freeze took hold, have all been recovered. And stranger still, the permafrost holds not just the dead, but the sleeping. Scientists have successfully germinated seeds from an ice age flower that had been frozen for over 30,000 years, and have even revived microscopic bacteria and viruses that have lain dormant in the ice since long before modern humans walked the earth. A quiet testament to the enduring tenacity of life. Beneath this layer of preserved life, locked even deeper in the permafrost and under the cold seabed, lies a different kind of sleeping giant. A vast, concentrated reserve of ancient energy. Here, under conditions of high pressure and low temperature, methane gas, produced by the slow decomposition of organic matter long ago, becomes trapped inside a crystalline cage of frozen water molecules. The resulting substance is a strange, ice-like solid known as a methane hydrate, or a clathrate. It looks like white ice, but if you were to bring a flame near it, it would burn, releasing the methane gas locked within its crystal lattice. The quantity of methane stored in these hydrate deposits around the world is thought to be immense, potentially dwarfing all other fossil fuel reserves combined. It is a colossal store of carbon, held in a fragile, frozen state. And the land itself, this frozen ground, is not static. When permafrost, which can be composed of more than 50% ice, begins to thaw, the ground loses its structural integrity. The ice melts, the water drains away, and the land subsides and collapses, creating a unique and often chaotic landscape known as thermokarst. Hillsides slump, vast pits and craters appear seemingly overnight, and forests of tilted, drunken trees lean at bizarre angles as the earth gives way beneath them. It is a visible sign that the sleeping giant is beginning to stir, a fragile world of frozen history that is now facing a warmer future. But the dominion of the cold is not an absolute one, for even beneath the most ancient ice sheets and the deepest layers of permafrost, there is a persistent, upward whisper of warmth from our planet's molten heart. The cryosphere, the world of ice, does not rest upon a cold, dead foundation. It rests upon a living, breathing planet, and this connection creates a hidden world of drama and dynamism at the boundary between fire and ice. The most fundamental expression of this connection is the constant, gentle flow of geothermal heat. The Earth's core is a sphere of molten iron as hot as the surface of the sun, and this immense heat radiates slowly outwards through the mantle and the crust. The flow is subtle, on the order of milliwatts per square meter, an amount of energy far too small for us to ever feel on the surface. But when it is trapped beneath a miles-thick insulating blanket of ice, its effect becomes profound. This is the heat that maintains the liquid nature of subglacial lakes, and it is a quiet, steady force that is constantly influencing the behavior of the great ice sheets from below, a planetary heartbeat, setting a slow, deep rhythm for the world of ice. In certain places, however, this heartbeat becomes a roar. In geologically active regions like Iceland or West Antarctica, which sits atop a massive volcanic rift system, this geothermal influence is not a gentle whisper, but a direct and powerful force. Here, active volcanoes lie buried beneath thousands of feet of solid ice. It is a surreal and paradoxical marriage of opposites, a furnace entombed within a freezer. When one of these subglacial volcanoes erupts, the event is unlike any eruption on Earth's surface. The searing heat of the magma does not produce towering clouds of ash or flowing rivers of lava. Instead, it unleashes its phenomenal energy directly into the base of the ice sheet, melting colossal quantities of ice in a very short amount of time. A vast lake of meltwater can form within the volcano's caldera, trapped beneath the ice, until the pressure becomes so great that it lifts the ice sheet above it and bursts out in a catastrophic flood, a phenomenon known in Iceland by the name Jökulhlaup. This is a terrifying expression of the power of this hidden union, a wall of water, ice, and rock that can have a flow rate greater than any river on the planet, thundering out from under the glacier's edge and reshaping the entire landscape in a matter of hours. Beyond these dramatic eruptions, a more subtle and perhaps more widespread interaction may be occurring. In the deep sea, we are familiar with hydrothermal vents, or black smokers, which are fissures in the ocean floor that spew superheated, mineral-rich water from the Earth's interior, supporting vibrant ecosystems of chemosynthetic life. It is highly probable that similar hydrothermal vent systems exist at the base of the ice sheets in volcanically active areas. These vents would create localized oases of warmth and chemical energy, potential hotspots for the kind of unique, isolated microbial life that might also exist in subglacial lakes. It is a tantalizing vision, a hidden garden of life, thriving in the dark, warmed by the Earth's fire, and shielded from the world by a roof of ancient ice. This geothermal influence also plays a critical role in the way the great ice sheets move. The ice does not flow as a uniform, homogeneous mass. Instead, it is organized into a network of slow-moving regions and fast-flowing arteries known as ice streams. These ice streams are veritable rivers of ice, flowing up to 100 times faster than the surrounding ice sheet, and they are responsible for draining the vast majority of the ice from the interior of the continent out towards the sea. The location of many of these ice streams appears to be controlled by what lies beneath them. In areas where the geothermal heat flow is higher, more meltwater is produced at the base of the ice. This increased lubrication allows the ice to slide more easily and rapidly over the bedrock, creating one of these fast-flowing corridors. The shape of the bedrock and the geology beneath the ice also play a crucial role. But this subtle, unseen pattern of planetary heat helps to dictate the pathways and dynamics of these vast, frozen rivers. And so, deep beneath the white silence, these two fundamental forces of our planet, the inner fire and the outer ice, are locked in a silent, hidden dance, a dialogue of heat and pressure that shapes the flow of continents of ice and writes the story of the frozen world from the bottom up. After our long journey through the deep darkness, where fire meets ice, we now begin our slow ascent, returning towards the sun to witness a final, breathtaking collaboration between the glacier and the light. We arrive in a place that feels like a dream, a temporary and magical chamber that exists entirely within the body of the ice. This is a glacial ice cave, one of nature's most ephemeral and beautiful creations. To step inside, one is to leave the familiar world behind and enter a sanctuary of impossible color. A crystal palace sculpted not by human hands, but by the patient flow of water. The air grows still, and the only sound is the gentle, rhythmic dripping of meltwater, the slow pulse of the glacier's heart. And all around us is a deep, luminous, and otherworldly blue. The light that filters through the roof of translucent ice is transformed, imbued with the ancient spirit of the glacier itself. And the entire chamber glows as if lit from within by a soft, sapphire fire. This ethereal beauty is the result of the same physics that gives deep glacial ice its color, but experienced in a far more immersive and intimate way. As the white light of the sun strikes the roof of the cave, it passes from the air into the dense, crystalline medium of the ice. The journey through this ice acts as a filter. The tightly bound water molecules are perfectly structured to absorb the longer wavelengths of light, the reds, oranges, and yellows, quenching their energy. The shorter, higher energy wavelengths of blue and green light, however, are able to penetrate through the ice, scattering and reflecting off the internal crystal faces until the entire space is filled with their pure, cool radiance. To be inside an ice cave is to be inside the color blue, to breathe it and feel it, a direct and sensory experience of the fundamental physics of light and water. These crystal palaces are not permanent features of the landscape. They are the fleeting architecture of the summer melt. Most ice caves are formed by the action of running water. In the warmer months, meltwater on the glacier's surface will often find a crevasse or a weak point and begin to tunnel its way downwards, carving a channel through the ice, just as a river carves a canyon through rock. This subglacial river, flowing under immense pressure, can excavate vast caverns and winding passages at the base of the glacier. When winter returns and the melting slows or stops, the river may recede, revealing for a short time the beautiful, scalloped, and polished tunnel it has created. Each cave is therefore unique, a snapshot of a single season's hydrology, a temporary cathedral that will likely collapse or be filled by the glacier's relentless flow by the following year. Their very impermanence is a part of their profound beauty. As the light fills these transient spaces, it plays in strange and beautiful ways. The curved, water-polished walls of the ice act as both lenses and mirrors. The light is bent by refraction as it passes through the varying thicknesses of the ice, creating distorted, dreamlike views of the world outside. It is reflected from the shimmering surfaces, creating dazzling highlights and deep, velvety shadows. In some places, a beam of sunlight might find a perfectly angled facet and be focused into a brilliant, concentrated shaft of light, while in others, the light diffuses into a soft, uniform glow. And within the ice itself, a final, subtle secret of light can be found. An ice crystal has a property known as birefringence, which means that it splits a single ray of unpolarized light into two separate rays, which then travel at different speeds and on different paths through the crystal. We cannot perceive this effect with our naked eyes, but under the right conditions, this property can reveal the hidden stresses within the ice. As the glacier flows and grinds its way downhill, immense stress fields are created within its crystalline structure. These stresses alter the way the ice interacts with polarized light from the sky, and can be revealed as faint, beautiful, rainbow-like bands of color frozen within the blue. It is as if we are seeing the lines of force, the frozen memory of the immense pressures that shaped this solid river. And so we find ourselves resting in this silent, luminous space. It is a place of profound peace, a sanctuary carved not from stone, but from time and pressure, and water and light. It is a reminder that even in the heart of this immense and powerful body of ice, there can exist a space of the most delicate and transient beauty, a final, gentle gift from the hidden world beneath the white snow. And this cathedral of light, this entire frozen world, from the six-sided symmetry of a single snowflake to the continental scale flow of a vast ice sheet, owes its existence to the strange and deeply unique character of the single molecule from which it is built. Our journey now takes us to the smallest possible scale, to the invisible architect of all the wonders we have seen, the water molecule itself, H2O. It is a deceptively simple arrangement of three atoms, yet its behavior is so complex and anomalous that it continues to puzzle the scientists who study it. The key to its magic lies in its polarity. The single oxygen atom holds a slight negative charge, while the two hydrogen atoms on one side hold a slight positive charge, giving the molecule a front and a back. This polarity turns each water molecule into a tiny magnet, and they are irresistibly drawn to one another. The positive hydrogen side of one molecule is attracted to the negative oxygen side of another, forming a weak connection called a hydrogen bond. This bond is not a true, strong chemical bond. It is more like a form of molecular stickiness, a constant, fleeting attraction. In liquid water, these bonds are constantly forming, breaking, and reforming in a chaotic, frenetic dance that lasts for mere trillionths of a second. But when the water cools and begins to freeze, this dance slows down. The molecules move less erratically, and the hydrogen bonds are able to assert their influence, guiding the molecules into the most stable and low-energy configuration possible. The beautiful, open, hexagonal lattice of solid ice. This is the fundamental blueprint, the whispered instruction from which all the six-sided symmetry of the frozen world emerges. This transition from a chaotic liquid to an ordered solid holds water's most famous and life-giving anomaly. Almost every other substance in the universe becomes denser as it cools and solidifies. A piece of solid iron will sink in molten iron, a piece of wax will sink in liquid wax. But water behaves differently. As it cools, it does become denser, but only down to a temperature of 4 degrees Celsius. Below this point, as the hydrogen bonds begin to line up the molecules into the open hexagonal structure of ice, the water actually starts to expand, becoming less dense. This is why ice floats. This simple fact is one of the most important conditions for life on our planet. If ice were denser than water, it would sink as it formed. In winter, lakes, rivers, and even the oceans would freeze from the bottom up, becoming solid blocks of ice that the summer sun could never fully thaw. The aquatic world would be a desolate and lifeless place. Instead, the floating layer of ice that forms on a lake's surface acts as an insulating cap, protecting the liquid water below, which remains at a cozy 4 degrees Celsius at its densest point, allowing fish and all other aquatic life to survive the winter. It is a quirk of chemistry, a strange and beautiful exception to the rules that creates a sanctuary for life. The hexagonal ice we are familiar with is just one chapter in the story of frozen water. Under conditions of extreme pressure and temperature, far beyond anything found naturally on Earth's surface, water molecules can be forced into a bewildering variety of different crystalline structures. This property is known as polymorphism. To date, scientists have identified at least 19 distinct forms of crystalline ice, each with its own unique geometry and properties, given names like Ice 2, Ice 3, and so on, all the way up to Ice 19. There is cubic ice, which forms in the upper atmosphere, and rhombohedral ice, and even forms of hot ice that can remain solid at temperatures far above boiling as long as the pressure is millions of times greater than our own atmosphere. This demonstrates the incredible versatility hidden within this simple molecule, a chameleon of a substance that can adopt a vast array of forms in response to its environment. And even with all we know, this familiar substance still holds its puzzles. For centuries, people have observed a counterintuitive phenomenon known as the Mpemba effect, the observation that, under certain specific conditions, hot water can appear to freeze faster than cold water. The effect is real, though the precise reasons for it are still debated by physicists, with possible explanations involving dissolved gases, convection, or the differing structures of hydrogen bonds in hot and cold water. It serves as a gentle reminder that this substance, which we drink and bathe in and see fall from the sky, is a liquid of profound complexity, a substance that still holds its secrets close. It is the water that remembers its hexagonal destiny, the architect of a world of crystal, the silent, essential foundation for the entire hidden world beneath the white. And this masterful architect, this water molecule with its strange and beautiful rules, has not limited its creations to our own world. For when we lift our gaze from the earth to the silent, velvet darkness of space, we see echoes of its work, and the work of other frozen volatiles, scattered like jewels across the solar system. The same fundamental laws of physics and chemistry that govern the formation of a single snowflake also shape entire worlds of ice, making these distant, alien landscapes feel at once both profoundly strange and deeply, intimately familiar. Our cosmic journey begins with our nearest planetary neighbour, Mars. The red planet, though now a cold and arid desert, bears the unmistakable scars of a warmer, wetter past, and it still clings to the remnants of its water in its polar ice caps. These are not simple sheets of ice like our own. The Martian poles are layered structures, a dynamic mixture of familiar water ice and frozen carbon dioxide, which we know as dry ice. With the turning of the Martian seasons, which are nearly twice as long as our own, these caps perform a slow, planetary-scale dance of breath. In the winter, the atmosphere itself freezes, and a thin, seasonal layer of carbon dioxide snow falls, extending the cap's reach. In the summer, this dry ice sublimates, turning directly back into a gas and retreating, revealing the permanent, thicker cap of ancient water ice that lies beneath. It is a quiet, rhythmic pulse, a familiar cycle of winter accumulation and summer melt playing out on a distant, silent world. Journeying farther out into the realm of the gas giants, we arrive at the moons of Jupiter, and here we find a world that has become one of the most tantalizing locations in our search for life beyond Earth. This is Europa, a moon slightly smaller than our own, with a surface that is a bright, chaotic maze of crisscrossing cracks and ridges of solid water ice. But the true wonder of Europa lies beneath this frozen shell. The gravitational pull of the colossal planet Jupiter is so immense that it constantly kneads and flexes Europa's interior, creating a powerful tidal friction that generates a tremendous amount of heat. This internal heat is believed to be enough to maintain a vast, globe-spanning ocean of liquid salt water hidden beneath the ice, an ocean that may be over 60 miles deep and contain more than twice the amount of water as all of Earth's oceans combined. Here, protected from the harsh radiation of space by its icy roof, is a world of liquid water, darkness, and potential chemical nutrients seeping up from the rocky seafloor. It is a perfect echo of the subglacial lakes of Antarctica, but on an oceanic, planetary scale, a hidden, dark sea where life could potentially arise and evolve, powered not by the light of the sun, but by the same chemosynthesis we imagine in the depths of our own world. This interplay of gravity and ice creates even stranger phenomena in other corners of the solar system. On Saturn's small, bright moon, Enceladus, and on Neptune's large, captured moon, Triton, we have witnessed one of space's most surreal sights. Cryovolcanism. These are not volcanoes of molten rock, but volcanoes of ice. On Enceladus, immense plumes of water vapor, ice particles, and other volatile compounds have been seen erupting from great fissures near its south pole, blasting hundreds of miles out into space. These icy geysers are evidence of another subsurface ocean, a reservoir of liquid that is being vented into the cosmos. On the even colder and more distant Triton, nitrogen gas, warmed by the faint sun, can build up pressure beneath a surface of frozen nitrogen and erupt explosively, carrying dark, methane-rich dust high into the thin atmosphere. And finally, on the very edge of our solar system, on the dwarf planet Pluto, we find a landscape of truly exotic ices. Here, the mountains are made not of rock, but of water, ice frozen so hard it has the strength of granite. And through the valleys between these mountains flow vast, slow-moving glaciers, made not of water, but of frozen nitrogen and methane. This soft, volatile ice flows and carves the landscape just as our own glaciers do, creating a familiar pattern with utterly alien materials. From the carbon dioxide snows of Mars to the nitrogen glaciers of Pluto, the universe speaks in a language of freezing and flowing, a cosmic narrative written in crystal. While these distant worlds of ice move in a silence we can only imagine, the frozen landscapes of our own planet are filled with a voice, a deep and powerful symphony of cracking and carving, the sound of a world in a constant state of dynamic, forceful motion. The great white silence is not truly silent. It is a place of profound acoustic drama, a concert hall for the immense forces of gravity and ice. To stand near the terminus of a tidewater glacier is to witness and to hear the most thunderous and spectacular event in the cryosphere's repertoire, the act of carving. Here, where the river of ice meets the sea, it becomes an unstable cliff, its face a wall of blue and white ice towering hundreds of feet above the water. As the glacier flows forward, and as the warmer ocean water melts its base from below, this cliff is constantly undermined. The stresses build to an impossible tension, until, with a deafening crack that echoes for miles, a vast section of the glacier's face gives way. An iceberg, which can be the size of a city block or a small island, splits from the mainland of the glacier and plunges into the sea with a deep, visceral roar. The impact creates a monumental wave, a localized tsunami, and the newly born iceberg, finding its own buoyancy, will often roll and capsize in the water, a slow, groaning motion of a mountain finding its balance. This is the glacier's exhalation, the final moment in the long journey of a snowflake, as it is returned at last to the ocean from which it came, its departure announced with a sound of elemental power. Beyond these dramatic crescendos, the glacier speaks in a more constant, subtle language. If you were to sit quietly on the surface of a moving glacier, you would hear its inner voice, a rich tapestry of sounds that reveal the immense strain within its body. There are deep, resonant booms, known as icequakes, which are the sounds of the ice fracturing internally as it flows over the uneven bedrock far below. There are high-pitched zings and creaks, as millions of tiny ice crystals adjust and slip past one another under the immense pressure. And when an iceberg floats in a quiet fjord, it will often produce a gentle, continuous fizzing sound, a phenomenon sometimes called the Bergy Seltzer. This is the sound of it releasing the ancient air that was trapped within its ice centuries or millennia ago. As the ice melts in the slightly warmer seawater, the highly pressurized bubbles of Ice Age atmosphere finally pop, releasing a whisper from a long-forgotten world. These are the intimate sounds of the ice, its groans and whispers, the acoustic signature of its slow, relentless life. Much of this cracking and carving is driven by the very water that the glacier produces. In the summer, meltwater forms lakes and rivers on the glacier's surface. This water is a powerful agent of change. When a surface river finds a crevasse, it will begin to pour into it, forming what is known as a moulin, a near vertical shaft that can carry water all the way to the glacier's base. The water can also pool in crevasses, and this is where the process of hydrofracturing begins. Water is denser than ice, and the sheer weight of a deep column of water in a crevasse exerts an enormous pressure at the crack's tip. This pressure acts like a wedge, forcing the crack to propagate deeper and wider, sometimes slicing completely through a floating ice tongue, priming it for a dramatic collapse. It is a quiet, hydraulic force that can break apart a mountain of ice from the inside out. And in the world of sea ice, in the polar oceans, there is another, much quieter and stranger phenomenon. When sea ice forms, it leaves behind a cold, extremely salty brine. This brine is denser than the seawater below and is supercooled, far below its normal freezing point. Sometimes, this brine will find a crack in the sea ice and begin to leak downwards in a thin, sinking plume. As this supercooled brine touches the fresher, warmer seawater around it, it instantly freezes that water, forming a hollow, growing tube of ice around the plume. This is a brinicle, a bizarre, underwater icicle that grows downwards from the sea ice towards the ocean floor. It is a silent, creeping finger of death, freezing everything it touches on the seabed, like starfish and sea urchins, entombing them in a sheath of ice. It is a quiet, deadly, and hauntingly beautiful display of the strange physics of the frozen sea. A silent note in the grand, and often thundering, symphony of the ice. But beyond this thundering, visible voice, the great ice sheets exert a far more profound and silent influence, a power that reaches from the frozen poles to the darkest depths of the equatorial sea, acting as the unseen architects of the deep ocean. The carving of an iceberg is a spectacular return of water to the sea, but the most important connection between the cryosphere and the world's oceans is an invisible, slow, and continuous process that drives the circulation of the entire planet. This is the Great Ocean Conveyor Belt, a global system of currents known as the thermohaline circulation, its name derived from the Greek for heat and salt, the two key drivers of its motion. It is a journey of water that can take 1,000 years to complete, a planetary-scale circulatory system that transports heat, nutrients, and gases around the globe, and its great, cold heart beats in the polar regions. The most powerful beat of this heart occurs in the seas surrounding Antarctica, where the coldest, densest, and most important water mass on Earth is born. It is called Antarctic bottom water, and its creation is a direct consequence of the formation of sea ice. As the frigid polar air passes over the ocean in the winter, it pulls the heat from the surface water, causing it to freeze. When seawater freezes, its crystalline structure cannot accommodate the salt ions, so the salt is expelled and left behind in the unfrozen water. This process creates a residual brine that is not only incredibly cold, just below the freezing point of fresh water, but also extremely salty. This combination of cold temperature and high salinity makes this water exceptionally dense, heavier than any other water in the ocean. And because it is heavy, it sinks. This sinking does not happen gently. The dense, salty water cascades down the Antarctic continental shelf in what can only be described as a great, slow-motion, underwater waterfall, a river of cold plunging into the abyss. This newly formed Antarctic bottom water then begins its long, slow journey northward along the ocean floor, a deep, dense current that will eventually spread out to fill the bottom of the Indian, Atlantic, and Pacific Oceans. It is a silent, invisible river, thousands of times larger in volume than the Amazon, and it is the primary engine of the deep ocean circulation. And this sinking river carries with it a precious gift for the deep sea: oxygen. The surface waters of the polar oceans, cold and constantly churned by the wind, are rich in dissolved oxygen absorbed from the atmosphere. As this water sinks, it carries this life-giving gas with it, delivering it to the abyssal plains, thousands of feet below the surface. This is the primary mechanism for the oxygenation of the deep ocean. Without this constant, cold respiration from the poles, the depths would become stagnant, anoxic, and unable to support the diverse ecosystems of strange and beautiful creatures that thrive there. The frozen breath of the polar world is what allows the hidden world of the deep sea to live. The vast floating ice shelves that fringe Antarctica play a crucial role in this process. These are the colossal, floating extensions of the land-based glaciers, some as large as a country, and their interaction with the ocean beneath them is a critical part of the story. As warmer ocean currents circulate under these ice shelves, they melt the ice from below. This infusion of fresh, cold meltwater subtly alters the temperature and salinity of the surrounding seawater, influencing the precise conditions needed for the formation of the sea ice and the dense bottom water. The ice shelves act as great moderators and mixers, their silent, hidden melting chambers being the place where the land ice and the ocean finally meet and influence one another. And so, our deep journey into the hidden world beneath the snow culminates in this understanding of a profound and planetary scale connection. The quiet formation of sea ice around a frozen continent, a seemingly remote and simple process, is in fact the driving force of a global system, a silent architect that ventilates the deep oceans, transports heat around the world, and shapes the climate of our entire planet. It is the final revelation of the ice, that its stillness and coldness are the source of a powerful, life-giving, and eternal motion. And as this great, slow current of bottom water begins its silent, thousand-year journey through the abyss, we too begin a new journey, turning our gaze away from the vast mechanics of the planet and inward to the quiet landscape of the human heart as it stands in the white silence. For these frozen worlds are not just geological and biological systems, they are also places of profound emotional and psychological resonance, landscapes that have shaped our stories, our cultures, and our very sense of self. To stand in a world freshly covered in snow is to stand in a world transformed, a world simplified and purified. The bright, uniform whiteness that covers every complex and distracting detail of the ground can have a deeply calming effect on the human mind. The psychology of color suggests that white evokes feelings of peace, clarity, and new beginnings. It is a blank page upon which we can project our own thoughts and feelings. This visual simplicity is amplified by the profound quiet that we explored so long ago. The absorption of sound creates a space of deep stillness, muffling the noise of the outside world and allowing the quiet, inner voice of our own consciousness to be heard more clearly. A walk through a snowy wood can become a walking meditation, a journey into a space that feels both external and deeply internal, a place where the boundary between the self and the world can feel beautifully, peacefully blurred. This connection to the natural world, this sense of awe and peace in a winter landscape, is a part of our innate biophilia, our deep-seated love for the living world. While we may think of winter as a time of dormancy, the beauty of a snowy landscape can evoke a powerful sense of wonder. But it also creates a unique feeling of coziness and security. There is a specific and cherished human experience, given names like hygge in the Danish language, that describes the feeling of being in a warm, safe, and comfortable place while the cold, wild world is just outside. The snow, in this sense, helps to define the sanctuary of our homes. The thick blanket of white that covers the world outside makes the warmth of the fire, the light of a candle, and the company of loved ones feel all the more precious and protected. The snow creates the very conditions for this feeling of deep, contented security, a gentle paradox where the harshness of the outer world gives birth to the peace of the inner one. For those cultures that have lived in these frozen landscapes for millennia, this connection is far deeper and more nuanced than simple appreciation. For indigenous peoples of the Arctic, like the Inuit of North America or the Sami of Northern Europe, snow and ice are the very fabric of existence, and their understanding of it is a sophisticated and essential science in its own right. Where we might have only one word for snow, these languages have dozens of distinct, precise terms for different conditions. For the fine, powdery snow that is good for travel, for the wet, heavy snow that is dangerous, for the crystalline hoarfrost that signals a change in weather, for the rippled, wind-blown sastrugi that can be used to navigate. This is not just a rich vocabulary, it is a system of knowledge, a way of reading the world with an intimacy and precision born from thousands of years of careful observation and passed down through generations. It is a reminder that there are many ways of knowing the world, and that the deepest understanding often comes from a life lived in direct, respectful, and dependent relationship with the environment. In the most extreme of these environments, the world can become a place of pure sensory abstraction, To be caught in a whiteout, where the falling snow and the snow-covered ground merge into a single, seamless field of white with no horizon, is to be untethered from the normal cues of space and time. It can be a disorienting and dangerous experience, but it is also a state of profound sensory deprivation that can lead to an altered state of consciousness, a deep introspection where the external world dissolves, leaving only the landscape of the mind. In the great, white silence, we are often left with no company but ourselves, and it is in this quiet that we can begin to understand the deep and resonant connection between the outer wilderness and our own inner world. And from this deep, internal stillness of the human heart, we are gently summoned back to the outer world by a new sound, the softest of whispers that soon grows into a steady, liquid rhythm. The sound of the thaw. As the days lengthen and the sun begins to climb higher in the sky, its rays strike the snow with a newfound strength. The first sign of the great change is a subtle shift in the texture of the light, a glistening on the surface of the snow, as the very tips of the ice crystals begin to lose their solid form. Then comes the first drop of meltwater, a single, perfect sphere that hangs for a moment before letting go, a sound that is the antithesis of the winter silence. Soon, one drop is joined by another, and a gentle percussive music begins to fill the air, a melody of dripping from the eaves of houses and the bare branches of trees. This is the beginning of the great release, the slow, patient unlocking of winter's grip. The process is a gradual one, a testament to a remarkable property of water known as its latent heat of fusion. It takes a single calorie of energy to raise the temperature of a gram of liquid water by 1 degree Celsius, but it takes nearly 80 calories to break the hydrogen bonds of a gram of ice and turn it into liquid water at the same temperature. This immense energy requirement means that the snowpack has a tremendous thermal inertia. It cannot melt all at once. It must first absorb a vast amount of the sun's warmth, slowly weakening its internal structure, before it can begin to release its water in earnest. This property acts as a great planetary moderator, ensuring that the transition from winter to spring is a gentle one, a slow crescendo rather than an abrupt and catastrophic flood. As the thaw gathers momentum, this meltwater begins to move, to seek its way downwards, first percolating through the snowpack itself, and then, as the ground unfreezes, flowing over the surface of the land. Tiny rivulets merge to form small streams, which in turn feed the awakening rivers. This is the spring freshet, the annual pulse of life-giving water that is the defining event of the season for so many of the world's ecosystems. The rivers, which had been slow and quiet under their winter ice, now swell and quicken, their voices rising to a joyful rush. This surge of water is the awakening of the landscape's circulatory system, carrying the memory of the mountain snows down to the thirsty valleys and plains below. It fills the wetlands, recharges the groundwater, and provides the essential moisture needed for the explosion of life that is about to begin. It is the great drink of water for a world that has been sleeping for months. And this water is not just water, it is a rich and nourishing tea. Throughout the long winter, the snowpack has been acting as a gentle filter for the atmosphere, trapping particles of dust, pollen, and other aerosols that drift down from the sky. These particles are often rich in essential nutrients like nitrogen and phosphorus. The spring melt liberates this stored fertility, carrying these nutrients into the soil and the waterways, where they provide the first, crucial meal for the awakening world. The algae in the ponds, the microbes in the soil, and the just sprouting roots of the perennial plants all depend on this timely delivery of nourishment to fuel their first burst of growth. The snow, in its final act of melting, gives back to the world all the sustenance it has quietly gathered during its long, white slumber. In the chemistry of the meltwater itself, a final, subtle story is told. As the snowpack melts, the water molecules containing the lighter isotopes of hydrogen and oxygen are able to break their bonds and escape the ice crystal structure more easily than their heavier counterparts. This means that the very first trickles of meltwater are isotopically lighter than the snowpack as a whole. As the season progresses and the melt continues, the remaining snow becomes more and more enriched in the heavier isotopes, a subtle chemical signature that scientists can use to trace the water's journey and understand the dynamics of the thaw. It is a final, quiet memory, a chemical fingerprint that reveals the slow, ordered, and beautiful process of the world's reawakening. And as this meltwater carries the subtle, isotopic memory of a single season, the great ice sheets themselves hold the memory of epochs, offering us a message written in the quiet, profound language of deep time. Our journey has taken us deep into the hidden mechanics of the frozen world, but for these final moments, let us simply rest in the perspective that this world offers. To contemplate the vast, slow story held within the ice is to find a sense of peace that transcends the hurried pace of our own lives. When we look at a cross-section of an ice core, we see the clear, annual layers of snowfall stretching down and down, a vertical calendar of winters past. Near the very top, in the most recent layers, a new and unmistakable signature appears. It is a thin, dark band of soot, a sharp increase in the concentration of methane and carbon dioxide in the trapped air bubbles, a trace of industrial metals. This is the mark of the Anthropocene, the geological signal of our own time. To see it is not to feel alarm, but to feel a sense of profound context. Here we are, a visible line in the ice, a single, recent sentence in an immense and ancient book. Our entire history as a civilization is recorded in a layer of ice so thin you could cover it with your hand. Below it lies the deep, clean ice of the Holocene, the 10,000 years of stable climate that nurtured our growth. And below that, the layers continue, down and down, into the deep, cold heart of the last ice age. As we descend through these layers, we see the grand, natural rhythms of the planet unfolding. The ice reveals the great cycles of the ice ages, coming and going with a slow, predictable pulse over hundreds of thousands of years. These cycles are driven by the quiet, celestial mechanics of our solar system, the subtle, slow changes in the Earth's orbit around the Sun, the gentle wobble of its axis, and the changing tilt of its spin. These are the Milankovitch cycles, named for the scientist who first calculated their rhythm. They are the true heartbeat of the planet's long-term climate, a deep and steady breath that inhales and exhales continents of ice on a timescale that dwarfs human comprehension. To contemplate this rhythm is to feel our own anxieties diminish. Our lives, and even our entire history, are a fleeting moment riding atop these vast, slow, and powerful waves of planetary change. The ice teaches us a lesson in humility and perspective, connecting our present moment to a story of unimaginable length and patience. And the story goes deeper still. The ice in our cores takes us back almost 1,000,000 years, but the geological record tells of even more profound frozen epochs. There is a theory known as snowball Earth, which suggests that on at least 2 occasions in the deep past, over 600 million years ago, our planet may have been almost entirely covered in ice, a gleaming white sphere tumbling through space. It would have been a state of unimaginable stillness, a world locked in a frozen slumber for millions of years. And yet, it was not an end. It is thought that from the crucible of this extreme cold, as volcanoes eventually punched through the ice and released their warming gases, the conditions were set for the explosive evolution of complex, multicellular life. The ice, in this story, is not a force of death, but a gateway to a new and more vibrant form of life. And as we reach into the deepest parts of our planet's past, we encounter a final, gentle mystery. The faint young sun paradox is the puzzle that when life first arose on Earth billions of years ago, the sun was significantly dimmer and weaker than it is today, perhaps by as much as 30%. By all calculations, the Earth should have been a frozen, lifeless ball of ice. Yet we know that it was not. It had liquid oceans and the beginnings of life. The precise mechanism that kept our young planet warm is still a subject of scientific wonder and debate, a quiet reminder that the story of our world, and the role that ice and warmth have played within it, is a story we are still learning to read. It is a story of resilience, of balance, and of a past so vast and deep that it can hold all of our present worries in a silent, peaceful, and eternal embrace. And as we rest in this deep embrace of geological time, we bring our awareness gently back to the present moment, to this thin, precious layer of ice that exists right now, and we see it not just as a record of the past, but as a living, breathing system of immense and gentle fragility. The great story of the ice is one of constant change, of advance and retreat, of cycles that unfold over millennia. The changes we see in our own time are a part of this story, a new chapter being written in that thin layer at the very top of the ice core. To observe this change is not to be alarmed, but to appreciate the delicate balance that governs this frozen world, and to feel a sense of profound love for its transient beauty. One of the most fundamental principles of this balance is the ice albedo feedback loop, a form of planetary momentum. We have seen how the bright white surface of snow and ice reflects the sun's energy back into space, helping to keep the world cool. As the climate warms, however, and the ice begins to melt and retreat, it exposes the darker surfaces that lie beneath it, the deep blue of the ocean or the dark soil and rock of the land. These darker surfaces do the opposite of the ice. They absorb the sun's warmth, which in turn warms the air and the water, which in turn causes more ice to melt, which in turn exposes more dark surfaces. It is a self-reinforcing cycle, a quiet and powerful process where a little bit of melting can naturally lead to more. It is as if the Earth, by losing its bright, reflective shield, begins to absorb the warmth it once held at bay. As the great land-based ice sheets of Greenland and Antarctica feel this warmth, they begin to contribute their ancient frozen water back to the sea. This is the source of the slow and steady rise in global sea levels. It is a simple and direct consequence. When ice that is resting on land melts and its water flows into the ocean, the volume of the ocean must increase. It is a process of immense scale, but it happens with a quiet, inexorable slowness, a silent sigh of water returning to its source after an imprisonment of thousands of years. But the changes are not just physical, they are also chemical. The world's oceans are the planet's great absorbers of carbon dioxide from the atmosphere, and the cold polar seas are especially good at this. As the concentration of CO2 in the atmosphere has increased, these cold waters have absorbed more and more of it. When carbon dioxide dissolves in water, it forms carbonic acid, a weak acid that gently lowers the water's pH, making it more acidic. This process of ocean acidification poses a silent, invisible challenge to the creatures that form the very base of the polar food web. Tiny, beautiful sea snails called pteropods, and the microscopic plankton that build their delicate shells from calcium carbonate, find it harder and harder to do so in more acidic water. Their shells can become thinner, more fragile, or may even begin to dissolve, a subtle and profound stress on the smallest architects of the sea. And finally, the sleeping giant of the permafrost is beginning to stir. As the northern lands warm, the deep, ancient layers of frozen ground are beginning to thaw. The ice that has held this ground solid for millennia is turning to water, causing the landscapes to slump and change. But more importantly, the vast store of ancient organic matter, the frozen roots, leaves, and remains of Ice Age animals, is now being exposed to the warmth and oxygen it has been denied for so long. The microbes that have been dormant for eons are awakening, and they are beginning to do what they have always done: decompose this organic matter. And as they do, they release the carbon that has been locked away for so long back into the atmosphere in the form of carbon dioxide and methane. This release of ancient carbon adds to the warming, which in turn causes more permafrost to thaw, another one of the Earth's great feedback loops. To witness these changes is to feel a sense of deep poignancy. It is like watching a masterpiece of sand as a gentle wind begins to rise, or listening to a beautiful, fading echo. It is a call not to anxiety, but to love, a quiet invitation to hold this beautiful, fragile, and changing world in our hearts with a newfound sense of tenderness and care. But in the face of this immense and gentle change, our long journey together does not end with a feeling of sorrow, but with a return to the very beginning, to the small, perfect, and eternal truth of a single snowflake. We began our story in the high, cold atmosphere, watching a unique and beautiful crystal take form and drift slowly down to a sleeping world. Now, after all we have explored, from the hidden life in the subnivean realm to the ancient air in the heart of the ice, from the volcanoes burning under Antarctica to the nitrogen glaciers of Pluto, we return to this single, six-sided messenger. and we see it now not just as a fleeting piece of winter's art, but as a profound symbol of the entire, interconnected world. It is a perfect, miniature representation of the hydrological cycle, that endless and life-giving journey of water. It is born from the invisible vapor of the oceans. It falls to the earth to become a part of the snowpack, the river, the glacier, and in its eventual melting, its water flows back to the sea, ready to be lifted once more into the sky. It is a symbol of journey and return, of a cycle that has no beginning and no end. In its beautiful and intricate form, we can see a universal pattern that echoes throughout the natural world. The principle of fractal geometry teaches us that many things in nature have a self-similar structure, where the patterns of the whole are repeated in the parts. The 6 branching arms of our snowflake are a perfect example of this. And as we look closer at the world it helps to create, we see this same branching pattern everywhere. We see it in the delicate filigree of frost that spreads across a cold window pane. We see it in the way a great glacier spills into the sea, branching out into a network of fjords and inlets. And we see it in the deltas of the great rivers, fed by its meltwater, as they branch out into countless smaller channels on their final journey to the ocean. The snowflake, in its humble perfection, contains the geometric blueprint for the very landscapes it will go on to shape. It is a key that unlocks a universal principle of growth and form. And so, this single flake of snow, which once seemed so small and simple, has become for us a symbol of the deep and profound interconnectedness of all of Earth's systems. In its existence, we are reminded of the cryosphere, the world of ice. But we now know that this world cannot be separated from the others. It is connected to the atmosphere, whose ancient breath it holds captive in its bubbles. It is connected to the biosphere, for the life that it shelters under its blanket, and for the life it preserves in its frozen heart. It is connected to the lithosphere, the solid earth, whose inner fire warms it from below, and whose mountains it grinds to dust. And it is connected to the hydrosphere, the world of water, for it is the great engine of the deep ocean currents and the ultimate source of so many of the world's rivers. All of these systems, which we so often think of as separate, are in fact woven together in a single, beautiful, and intricate tapestry, and the bright, white thread of the frozen world runs through it all. Our journey beneath the white snow has revealed a world not of emptiness and stillness, but of hidden life, of deep memory, and of silent, planetary power. It is a world that invites us to slow down, to look closer, and to feel the profound peace that comes from understanding our place in a story so much larger than ourselves. Thank you for joining me on this long and quiet journey. I hope it has brought you a measure of peace and a sense of wonder. May your sleep be deep, restful, and filled with the most beautiful and silent of dreams. If you have found comfort here, please do return to this quiet space for more gentle stories. Until then, good night.